Hi, good day to you, and welcome to my channel where I tutor you in science for free. The topic in this video will be practical electricity, and this chapter has a main theme of safety of the users using the particular appliance. Okay, so let's get the boring stuff out of the way. Firstly, we have formulas. So we already learned Q is it, and then combining with QV equals W, Queen Victoria. Remember your earlier formulas? You can check it out in the earlier videos. Combining them together, you will get W equals to VIT, where work done equals to volt times current times time. Or sometimes work done is also rephrased as energy expended or energy converted. So E can also be equals to V times I times T. I call this the vitamin E formula. From earlier chapters, okay, power is the rate of doing work or rate of energy conversion, right? So P equals W over T, P equals to E over T, and replacing W with VIT, we will get this. So T cancels out, P equals to VI. These are the new formulas you need to know. Vitamin E and P equals to VI. Earlier formulas we also learned that V equals to IR, you sub it into E equals to VIT, you get E equals to I square RT, or if you use the V equals to IR, if you are using I equals to V over R, you'll get E equals to V square T over R. So these are just more formulas to your arsenal. I rarely see this being asked, just an observation, the V square T over R one. So energy that is being measured over here, work done, is energy expended or energy converted, is being measured in joules, J, it is a scalar quantity. And since P equals to VI, you can also put in the V equals IR and I equals V over R, you get another new formula, which is P power equals to I square R, or P equals to V square R. Power is measured in watt, also scalar. You would already have been exposed to this in the earlier chapters. Okay, and since this chapter is talking about electricity being used in a household and how you'll be safe from that, and also you need to know about calculation of the energy being converted. A common unit is kilowatt hours, kWh. Okay, 1 kilowatt, 1000 watt of power, okay, is used for 1 hour. So you can see that there's a formula staring at you already from the unit. Energy equals to power times time. So it's just power equals work done over time. You convert it to E over T, and then you make E the subject of the formula. Energy is the power times time. E equals to PT. Kilowatt is a unit of power, P, and an hour is a unit of time, T. So kilowatt hour is a measure of energy used. So 1 kWh is 1000 watt times 3600 seconds. So why is that so? Because there are 60 seconds in a minute, 60 minutes in an hour. So 60 times 60, 3600. So it's 3.6 times 10 to the power of 6 joules in 1 kWh. So let's go on to electrical hazards. That's why we are here in this video. Damaged insulation, overheating of cables, dam conditions. Damaged insulation, usually cables are doubly insulated, so each wire is doing different things. They are insulated, and as a bundle, they have one more layer of insulation. And if the insulation is frayed, the exposed wires can come into contact with the user carrying live electricity, causing harm to the user because of its high voltage. Overheating of cables is another hazard. A lot of current is being forced into a very narrow space due to overloading or due to poor contact. The danger of having poor contact is usually having a large current passing through a very small area. Poor contact means having a small area of contact, right? So a large current forcing into a very small area to go on to the next route. This causes high heat because there's a lot of resistance. Recall that area also affects resistance. Surface area also causes resistance. So next will be moisture, damp environment. The water that we are exposed to, normally they are not extremely pure. There are some salt component inside, there's some ions that are in small amounts, but these are sufficient enough to conduct some electricity. And having moisture reduces resistance. So if our hands are wet and we happen to be be exposed to like wires, electric current can pass through to the user a lot easier because resistance is a lot lower, and because of the ions that happen to be present inside conducts current also. So damp environment is another factor to look out for. So to combat all of this, there are some safety features that we will cover in this video. Fuses, circuit breakers, double insulation, earthing. So firstly, you look at fuse. It's a little component that looks like this. It has a common rating of 1, 2, 3, 5, 10, 13 amperes. What does it mean? It means that it only allows like that stated amount of amperes to pass through it. And you must also understand that electric current is not constant at all moments of time. It's a little bit like river current. Sometimes there's some moments it's a little bit higher than the next moment. So we cannot construct a fuse that only allows 5 amperes. Any small increment, very minuscule increment, will melt the wire in the fuse and the circuit will be cut. And this will bring more hassle than as a safety benefit. And it's always connected to the live wire. Live wire is the wire that brings current into the appliance. Neutral wire is the one that brings current out of the appliance. A very simple analogy would be a circuit battery, a light bulb circuit. The current that comes from positive terminal will be the live one. The wire that goes back to the battery will be the neutral one. Looking at the back of a mains plug, it looks like that. So this is a small video of me dismantling a mains plug. Okay, so once you open the back cover, you can see there are 3 points over here, very easy to remember. In Singapore, we have this MRT line called the Northeast Line, NEL, right? So N stands for neutral, and neutral, you think of policemen, they wear blue uniform. E, you think of earth, there's grass, there's flowers, so it's green and yellow. And life is brown, you think of a brown cow, they are alive, right? So it's brown in color, and the fuse is attached to the live pin. Okay, circuit breaker is the box that you usually see in apartment buildings. This is the one that will trip. The lever will be turned downwards when it faces a large surge of power, sometimes through lightning or sometimes through a faulty appliance that is suddenly drawing a lot of current. And if the circuit breaker detects that there are more than the stated allowed current is passing through it, it will trip. And this is reversible. You can just open the circuit box and turn the lever back on. In contrast to the fuse, once it's blown, you have to open out the plug and buy a new one and replace it manually yourself. Okay, next will be the earth wire. Earth wire is mainly used when there is a metal casing of an appliance. Why is that so? Because metal casing can become live if, let's say, the live wire gets frayed and there's some contact of the live wire to the metal casing. The metal casing will receive the live current, and if a user happens to touch it, then the user will be electrocuted. And because the electricity always wants to find a way back into earth or somewhere back to the neutral to complete the circuit, right? And you don't want to be a part of the circuit. So earth wires, usually there's no current passing through it. It's connected from the metal casing all the way back into the earth via the way the apartment building is being built. This way the current does not pass into the user. Double insulation is pretty self-explanatory. So if wires are already insulated, another layer is for further safety to prevent contact with live wire. So this is a little summary table to show you the safety features and its uses. And lastly, this topic also talk about the cost of electricity usage. And this is quite self-explanatory because it's very basic ratio. The question must give you the cost of using 1 unit of energy. The benefit that you're consuming via an appliance is the energy, right? The light, the fan, the aircon, whatsoever. And it's measured all in kWh. The question must give you how much dollars and cents cost to use 1 kWh. Then you can do your working. Okay, so with that, we go on to some questions. An electrical supply is used to light lamps in parallel, circuit shown below. What's the total current in I? So you have V, you have P, and you want to find the I down here. So PVI, PVI, and then you add them together because it's in parallel. Then you get this answer. Okay, circuit shown below. which circuit shows electrical energy transform at the greatest rate. So greatest rate means highest power, energy transform is work done, right? Formula for power P equals VI. V is same for all 4 circuits. You must find the one whereby the I is the greatest. This will have the least resistance, having the largest current. Okay, appliance O vacuum cleaner metal casing cleaner mains plug is wired incorrectly as shown. What is the effect of having the plug wired this way? The metal case will become live, right? Because the live brings the current upwards and it's also connected to the earth. So the current also flows into the earth wire and into the metal case. It costs 30 cents for 1 kilowatt hour to be used. How much will it cost? 60 watt for 10 hours. So you count 60 watt, you convert to 0.06 kilowatt times 10, then you times 30 cents. This is what you will get, $0.18. Why a bird can stand on an overhead high voltage transmission line with no harm. This is due to both of their feet having the same voltage. So imagine it's like both of their feet is on the same high level water slide current. No water is being passed into the bird because both feet are on same voltage. So if one feet is on high voltage and the other feet is on a low voltage, then that is going to cause harm to the bird. And this chapter will sometimes give you very long questions. This is an example: wind turbine, renewable energy. Say one disadvantage using this in Singapore. So of course, land is going to be a problem, amount of high rise that we have. So a graph shown describe how the power output varies with the wind speed. So describe questions, usually you have to sprinkle in some numerical values that you see in the graph. So it's 3 marks given over here. You look at the graph, obviously you can talk about this part 1, 2 and 3. So here to here is 0, here to here increase constantly from what value to what value, and here to here it maintains at this value from which time to which time. So describe and sprinkle in values, you should not go wrong. Okay, wind speed recorded 1 minute interval shown in this table. Estimate total energy produced in the 10-minute interval. Gave answer in joules. So using the graph, you can plot how much amount of energy is. You can plot the power output, then you calculate the energy generated for each second, and they will be in joules. Then you tabulate all of them up, and this is the answer. Explain why is it only an estimate, because it's not a constant thing. Wind speed is not constant and does not give such absolute values. So power output is not constant, energy generated also not constant. So energy generated is passed to houses far away, energy is wasted in the cables. So say I explain one method to reduce the amount of energy wasted. So a large part of it is because of resistance, right? So you use thicker wires. So less energy is lost as heat to overcome the distance traveled. Okay, last one. Different sections of mains cable have different lengths, different cross-sectional area. The current is the same in all sections. Some sections have equal areas, different lengths. State relationship between power loss in this section. Resistance proportional to length. Power loss is proportional to resistance. Therefore, power loss is proportional to length. If the wire is longer, more power is going to be lost. Equal length, different cross-sectional area. State the relationship power loss. Okay, so of course, smaller area, you have higher resistance. So the smaller the area, the more power is going to be lost, trying to overcome pushing current through a small area. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe, and share it with somebody who needs to see this. And I will catch you in the next video. Bye!